right, so now that we've got kind of the basics of a line down, we can kind of think about what the equation of the line is telling us. So we can read points x, y, z off the equation of the line, sketch it in 3D, etc. And so real quick, one thing that we can always see when we look at one of these vectors is kind of the point and the direction that generated it. So if somebody just handed you this vector for the equation of a line, then you could go ahead and look at the numbers attached to t, this -1, 1, and -2, and you would know that this line has to be parallel to the vector -1, 1, -2. Similarly, you could always tell that the point 3, 1, 4 is on the line from the way it's written. And you should be able to kind of undo that information. That's actually one of your homework problems. And so let's just try learning a little bit about what this line right here, 3 minus 2, 3 minus t, 1 plus t, and then our last component is 4 minus 2t. Let's just try and think about what it is. It's a line that lives in 3 space, so we're going to end up sketching it. You'll get to see my wonderful drawing skills again. But to sketch it, we need some information first. So let's ask, when does this line intersect the XY plane, where we're used to drawing 2D objects? If you're in the XY plane, that means z equals 0. So we should have 0 is equal to 4 minus 2t. This is our z component. So that tells us that 4 is equal to 2t, t is equal to 2. So then my x is equal to 3 minus t. That's 3 minus 2, that's 1. And my y is equal to 1 plus t. That's 1 plus 2, that's 3. So when I'm at the point 1, 3, 0, I'm on this line, but I'm also in the xy plane. So kind of we can imagine here's our coordinate system. Oh, that went better than last time. Here's x, y, and z. Let's see. There's 1, 1, 2, 3. That's a point on our line. And we already know that 3, 1, 4 is also on our line from here, 3, 1, 4. That's the point that was given to us. So we could also go ahead and sketch that one when I'm at x equals 3, y equals 1, and z equals 4. That's approximately right there. I'm still on this line. And so I know this line is going to do something like, no. All right, there we go. That's a sketch of our line. It's good. And right here, it's kind of like entering the XY plane. You could imagine this being a flat piece of paper, and the line is kind of coming up out of it. If I wanted to check if any random point is on the line, I would just have to check that's easier to see if I go back to this representation right here. Kind of if I imagine that I'm solving my 3 minus t is equal to x, that means 3 minus x is equal to t. If I've got my 1 plus t equal to y, that means my y minus 1 is equal to t. And if I've got 4 minus 2t is equal to z, that means I've got my 4 minus z over 2 is equal to t. Just solving this algebraically, move the z and t's to opposite sides, divide by 2. And if I want to point x, y, z to be on the line, then these three things have to be true at exactly the same time t. So I need 3 minus x equal to y minus 1 equal to 4 minus z over 2. And so I could check that for any random point. For example, 7, 1, 3, I guess. I would check 3 minus 7 is minus 4. 1 minus 1 is 0. So already I know that point is not on the line. But for example, if I plug in my point 1, 3, 0 that we just found a second ago, I've got 3 minus 1 is 2, check. 3 minus 1 is 2, check. 4 minus 0 is 4, divided by 2 is 0, is 2, which is equal to all the other things. So I know that the point 1, 3, 0 is on the line.